So in this video, we're going to be talking about like terms. Before we begin discussing what that is, there's a concept that you should know. So here on the screen, I have three different monomials, x, x squared, and x cubed. What you have to understand for when we're working with polynomials is even though all three of these look the same, they are all different. So x, or x to the power of 1, is not the same as x squared. These are two different things. And x squared is not the same as x to the power of 3. So whenever you see these, even though they all have x, you have to think of them as being different. You can almost think of them as being levels of the same thing. So x squared is like higher up compared to x, and x cubed, or x to the power of 3, is higher up than x squared. But they're different things. Now, what are like terms? Like terms are terms with the same variable and exponent on the variable. So what does that mean? If we have 3x squared and negative 7x squared, these are like terms. And the reason they're like terms is because they have the same variable with the same exponent. So this is an x squared and this is an x squared. Now if we had something else, if we had 5x and 4x squared, these are not like terms. And the reason they're not like terms is this first term is just an x, or an x to the power of 1. Remember, there's an invisible 1 there. And this one is an x to the power of 2. So even though they're both x's, the exponent is not the same. So these are different terms. They're not like terms. Now, why are like terms important? If we have like terms, we can actually add them together to simplify things. So for example, if we have 3x squared plus 2x squared, since these are like terms, they're both x to the power of 2, we can actually combine them, because it's almost like saying, okay, 3 iPhones plus 2 iPhones, how many iPhones do we have in total? We have 5. So our answer is going to be 5x squared. Again, the important thing, we have an x squared, we have an x squared, and then we just add the coefficients together. 3 plus 2 is 5. But you have to have that x squared in your answer. Here's another one. So first thing we have to do is we have to see, are these like terms? Well, the first one is an x squared, and the second term is just an x. So these are not like terms, so we cannot combine them. So these are different terms. We have an x squared and an x. They do not mix together. Let's look at a few more examples. If we have 7x plus 3x, pause the video and see if you can answer that one. So in this case, we would have the same terms. They're both x, so we add the coefficients and we get 10x. Let's try another one. 5x squared minus 3x squared. Pause the video, see if you can do this one. So we have the same terms. They're both x to the power of 2. So we can now combine them. Instead of adding, though, we're just subtracting the coefficients. So 5 minus 3 is 2. And the variable is x to the power of 2. Here's another one. So in this case, we have an x to the power of 2 and x to the power of 3. They are not like terms, so we cannot combine them. Now, sometimes we can have even bigger polynomial problems, and we have to see if we can combine terms. There's a few steps. The first step is you want to rearrange the polynomial so all like terms are beside each other. And then the second step is just combining the terms. So let's look at an example of a larger polynomial where we might have to combine like terms. So here we have a lot more terms. The first step is we want to put all like terms together. So we have to figure out, okay, which ones are like terms? Well, I see we have two terms that are x's, and I also see two terms that are just constants. So these are my pairs of like terms. And the first thing I have to do is I have to rewrite these so all the like terms are together. So all my x's are going to come to the front and my constants are going to be in the back. So I'm just going to rearrange the different terms. So my 2x plus 2x goes to the front. And I can see my x's are at the front and my constants are in the back. Now we've done the first step rearranging them, and now we just have to combine like terms. So I'm going to combine all the x's, and 2x plus 2x is 4x. And now I'm combining my constants. 1 minus 3 is -2. So this is my final answer because I cannot combine this anymore because I have an x and a constant. They are not like terms. I cannot combine them. So now we have 6 terms. It's longer, but it's going to be the same method. So first thing I want to do is I want to find all my like terms. I have my x squareds. I also have my x's. And I have my constants. And we just want to rearrange these all so they're right next to each other. So my 4x squared stays at the front, but I'm going to bring my other x squared, 2x squared, and then I'm going to have my x's together plus 5x plus 2x, and then my constants I'm going to put in the back, -8 plus 3. One thing I want you to notice is the sign in front of the number follows that number. So in this case, we have a negative in front of this 8. So when I move this 8 to the back, that negative follows that number. It does not stay in this position over here. It actually follows that 8. So that's very important. So I have my x squareds, I have my x's, and I have my constants all together. Now that's the first step, rearranging things. I want to combine everything to simplify it. 4x squared plus 2x squared is 6x squared. Again, you're not adding those exponents. It's not x to the power of 4. It's 6x squared. 5x plus 2x is 7x. And -8 plus 3 is -5. So notice I'm working downwards like we often do in math. Makes things a lot easier to follow. Let's try one more example. So what do I have here? I have my x's. I also have 2x squareds. And I'm going to rearrange them, and then I'm going to combine them. So the x squareds I'm going to put at the front because to the power of 2 that's the highest degree. And I have -4x squared. Again, because that negative is in front of that 4x squared, when I move it to the front, that negative is going to follow. I'm going to move -3x squared to the front, and then I have my x's in the back. Plus 2x plus x. And here are my x squareds. And now I just need to combine things. Negative 4x squared minus 3x squared. We're subtracting and we're becoming even more negative. So it's negative 7x squared and then 2x plus x. Well, one thing I want you to keep in mind is x. Remember, there is an invisible 1 here. So it's really 2x plus 1x, even though we can't see that 1. So in this case, 2x plus x is 3x. And again, to make sure we can't simplify further, we just look at these. They're different terms. We cannot combine them. They have to stay like that.